Hello and welcome to Algebra 2. Today is Thursday, September 24th, and our topic for today is called End Behavior. This means we're looking at the very ends of graphs to see how they are behaving or in which direction they're going. Okay, we're going to start off with some vocab that is going to ground us in the rest of the lesson today. So, first, we're going to consider standard form. A standard form polynomial is ax squared plus bx plus c. It can have more exponents than that, though. An example would be like negative 4x to the fifth plus x cubed plus x squared minus 3. So that's in standard form. Okay, our other form, our second and final form, is called factored form. Factored form is just made of factors. So it might look like x minus a, x plus b, and so on. An example of something in factored form is like negative 3, x minus 2, and these can have exponents, so squared, x plus 1. Okay, now, we have two more words to learn, but the meaning of these words changes a little bit depending on if we're in standard form or in factored form. So, our word is leading coefficient. A leading coefficient in standard form is the number in front, like a coefficient is a number in front, but it's in front of the variable with the highest power. The number in front of the variable with the highest power. So in our example, this leading coefficient will say LC is negative 4, because 5 is the highest power, and the number in front is negative 4. Okay, now let's consider leading coefficient in factored form. Leading coefficient in factored form is a little bit easier because it's just the number in front, the very first number in front. We're just going to say number up front. So from our example, our LC, leading coefficient here, is going to be this negative 3 because it's the number in front. Okay, our final word for the day, this down here is our first example. Our final word is degree. And the degree of a standard form polynomial is just the highest exponent. So the highest exponent wins out over everybody in standard form. So the highest exponent here is 5. We're going to say DEG for degree is 5. Great. And then, last but not least, we have degree in factored form is the sum, the total of all the exponents. So remember, sum means to add. So it's the sum, addition of all exponents. You got to be careful. Let's make sure we spell this right. Exponents. We need to be careful and look out for invisible exponents. So this negative 3 up front has no exponent because it has no x. Right here we have a 2, and then up here is an invisible 1. So our degree is just the sum of 2 and 1. So the total degree here is 3. Okay, pause and rewind wherever you need. Practice these ideas now. Okay, first one. We're just going to go real quick and identify degree and leading coefficient of each. First, this is in standard form. Okay, my leading coefficient is in front of the highest exponent. My highest exponent is 5, so my leading coefficient is positive 3. It's really important, we'll see in a minute, that it's positive or negative. And our degree, in standard form, is just the highest exponent, so the degree is 5. Done. Let's do another one. Call this example 2, pause wherever you need, make sure you're writing the original problems. This guy is in factored form. So our leading coefficient is just the number up front. That's negative 2. Let's write in our exponents. Negative 2 has no exponent because it has no variable. And on the factors, if you don't see an exponent, it's 1. So our degree is the sum of the exponents is 2. Okay, we're going to do a few more. Call this example 3. Make sure you pause and write the originals. This is in standard form. Now, this is a good one because from this we can see that the highest exponent doesn't always come first. So don't just take the first one you see. Actually check all the exponents to see which is really the highest. Leading coefficient is in front of the highest exponent, so it's positive 17, and our degree is 6. One last one. We're going to call this bad boy example 4. If we don't see a number up front, this is factored. If we don't see a number up front, it's an invisible 1. So our lead coefficient is positive 1. I have an exponent of 2, and I don't see 1 here, so it must be 1. So our degree is 2 plus 1 is 3. Okay. Now we're really going to learn how to apply these. With the information of leading coefficient and degree, we can determine the general shape of a graph. There are 4 cases. Okay, so our first case is if you have, so for leading coefficient, what we care about is positive versus negative. That's the only thing that makes a difference, not the number itself. For degree, we care about even versus odd. So all odd numbers have the same effect, all even numbers have the same effect for degrees. So our first case is positive lead and an even degree makes a nice upward parabola shape. I'm putting dots here because all we know for sure are what happens at the end. The middle can change, but at the ends, it's going to go all the way up on both sides. Okay, what if we have a positive, let's do, if we had a negative lead coefficient and still an even degree, same shape, except we're upside down now because it's negative. Okay, we can have a positive lead and an odd degree. That's going to start low and work its way up. Again, the middle can change. All we know are the 2 endpoints. Okay, what if I had a negative lead and an odd degree? It's going to flip the other way around. I'm going to go up to down. So all we know are the endpoints. The middle can change. Feel free to pause here if you need to catch up. Go to our next example. Oh, shoot. Let's talk about end behavior. So we can describe end behavior. So our notation for end behavior. We're going to say, and I'm going to draw this little squiggle as an example. Okay? For end behavior, we say as x approaches blank, f of x we say approaches for the arrow blank. And we fill the x's with positives, with either positive infinity or negative infinity. So this could be positive or negative infinity. And this could be positive or negative infinity. I think this will make more sense with an example, so let's dive in. Okay, it says identify the lead coefficient, the degree, and the end behavior. All right, this is in standard form. So my lead coefficient will be in front of the variable with the highest exponent. My highest exponent is 3. My lead is -4. And my degree is the highest exponent, which is 3. So for lead coefficient, I care about positive, negative. It is negative. For degree, I care about even and odd. This is odd. So I have a negative odd. I go back up to my chart. Okay, that's right here. This is the shape my graph is going to take. So I don't know what happens in the middle, but we're not concerned about that. I know on the left-hand side, it's going up, and on the right-hand side, it's going down. So here's how we use that new notation. We're going to say, as x approaches infinity. This expression here means the right-hand side of the graph. Because as the x values are approaching infinity, we're going to say f of x, the curve itself, does what? Well, what does this do on the right-hand side? It goes down. So we say f of x approaches negative infinity. This expression means the curve goes down. F of x is the curve, negative infinity is down. So all we're really saying here is on the right-hand side, the curve goes down. We know that from analyzing lead coefficient and degree. Okay, let's do the left-hand side. I'm going to mark that in blue. So to say on the left-hand side, we're going to put as x approaches negative infinity. Okay, this just means the left side of the graph because the x values are negative. Okay, what happens to the curve? It's going up. So we're going to say f of x approaches positive infinity, and this expression means the curve goes up. So all we've really said is on the right-hand side, the curve goes down. On the left-hand side, the curve goes up. But this notation helps us write it more accurately and with more academic language. So to review our process, we want the end behavior. This is really our goal. This notation here is end behavior notation. So we identify lead coefficient and degree. Negative odd always takes this shape. Then we make a little sketch, and it helps us analyze our end behavior. That's all for today, guys. Thanks.